Hello, hello! Good morning, good afternoon, or good whatever time it is. It's a bit cloudy here in the Bay Area today, but hey, perfect weather to cozy up with some fresh AI papers. ArXiv just dropped 335 new AI papers today, and we found 72 that stood out to us, and hopefully you'll find them interesting too. Don't let 72 scare you. You can drop off anytime. Hop in, check out a few, and stay as long as you like. Let's get started.
Researchers at OpenAI found that increasing inference time compute significantly improves large language model (LLM) robustness against attacks. They tested various attacks and found that in many cases, increasing compute reduced the attack success rate to near zero. This differs from previous work focusing on adversarial training or pre-training scale. Researchers at Google Research and Google DeepMind studied scaling laws for differentially private LLMs. They found that compute-efficient training configurations saved 5x to 100x compute compared to baselines, while maintaining comparable privacy and utility. Optimal model sizes were much smaller than predicted by non-private scaling laws. Researchers at Stanford University and the University of Washington, along with colleagues from other institutions, developed a simpler way to improve language model reasonings. They fine-tuned a model on just 1,000 examples and used a budget-forcing technique to control computation time. This achieved results comparable to larger, closed-source models. Researchers at MIT developed a new way to make language models more understandable. They use low-rank adaptation, LoRA, to fine-tune the model around a sparse autoencoder, SAE. This method is 3 to 20 times faster than previous approaches while achieving similar results. Researchers at ETH Zurich and Huawei developed a new LiDAR loop closure detection algorithm. It uses graph attention networks and semantic graphs to improve accuracy. The method achieved a 13% higher maximum F1 score on the semantic KTI dataset than a baseline method. Researchers at Google DeepMind created simulation streams, a new way to control LLMs in complex simulations. It uses a state-based approach with operators and an ECS architecture to maintain consistency across thousands of iterations. They tested it on 6 reinforcement learning tasks and a market economy simulation. Researchers at Google DeepMind explored using large language models for regression. They represent numbers as decoded strings, unlike traditional methods. This approach performs competitively on tabular tasks, even with limited data, and effectively estimates densities. Researchers at Yale University and Microsoft Research, along with a team from other institutions, developed E2Former. It's a new molecular modeling method that's 7 to 30 times faster than existing approaches. This is achieved by shifting computation from edges to nodes in graph neural networks. Researchers at the University of Tokyo developed Scalable Softmax, SSMax, a new function for transformer models. SSMax prevents attention fading, a problem where attention weakens with longer contexts. Tests showed SSMax models had approximately 0.008 lower training loss and handled contexts 20 times longer than usual. Researchers at Google Cloud AI Research and Google DeepMind developed SETS, a new method for improving large language models, LLMs. Unlike older methods, SETS uses the LLM's ability to self-check and correct its answers. This led to up to an 8.7% accuracy boost on complex reasoning tasks. Researchers at Princeton University tackled oversmoothing in graph neural networks, GNNs. Their new model, BIMP, uses nonlinear opinion dynamics. Unlike other models, BIMP's Dirichlet energy stays stable even at 1,000 layers. Researchers at Peking University and Carnegie Mellon University developed OMNIPHYSGS, a new method for 3D physics-based animation. It uses constitutive Gaussians to represent materials, unlike previous methods limited to specific material types. OMNIPHYSGS outperforms existing methods by 3% to 16% in visual quality and text alignment. Researchers at Harvard University have unified 3 AI explanation methods: feature, data, and component attribution. They show these methods use similar techniques like perturbations and gradients, despite being studied separately before. This new framework helps understand AI models better. Researchers at EPFL studied time-varying Bayesian optimization, TVBO. They found that even the best TVBO algorithm has a linear regret. This is the first study to provide algorithm-independent lower and upper regret bounds, explicitly linking performance to response time under mild assumptions. Researchers at Tsinghua University and Shanghai University of Finance and Economics developed a new way to find why AI models make mistakes. They use manifold compactness, a new metric that doesn't need extra data labels. Their algorithm tested well on 886 settings from a benchmark dataset. Researchers at Tsinghua University developed MPIFA, a new method for compressing large language models, LLMs. It uses pivoting factorization to reduce redundancy in low-rank representations, achieving 24.2% extra memory savings and 24.6% faster inference at 50% density. The method also minimizes error accumulation during reconstruction. Researchers at Tsinghua University and Real AI, along with a team from Peking University, studied the robustness of large language models, LLMs. They created a new defense, Diff-Text-Pure, achieving over 80% improvement in robustness against strong attacks. This defense also provides a certified lower bound on robustness, unlike previous methods. Researchers at Toyota Research Institute and Toyota Technological Institute at Chicago, along with other institutions, created MVGD. This diffusion model directly generates images and depth maps from new viewpoints, unlike previous methods. It was trained on over 60 million samples. Researchers at Tsinghua University and the University of Padova developed a new, dynamic sparse training method. It uses a brain-inspired approach to train large language models, LLMs, and transformers. With only 5% of the connections, they achieved better performance than fully connected models on machine translation tasks. Researchers at Carnegie Mellon University and MBZUAI, along with a team from other institutions, developed a new rank test for causal discovery. It handles discretized data, unlike previous methods. Figure 1 shows how discretization changes a rank 1 matrix to a rank 3 matrix. This new test uses permutations to estimate the null distribution, improving accuracy. Researchers at City University of Macau and China University of Petroleum, East China, along with colleagues from Tsinghua University, developed LKCA-Net for hyperspectral image super-resolution. They found the upsampling layer is computationally expensive and used low-rank approximation to speed up processing by several dozen to even hundreds of times compared to other methods. Researchers at the University of Tokyo developed Diffusion Latent Beam Search, DLBS, for better text-to-video generation. DLBS explores multiple video possibilities at once, improving accuracy. A 6-step look-ahead estimator further boosts performance, matching or exceeding results from methods with 32 times the computational budget. Researchers at the University of Southern California and Google DeepMind developed PSPL, a new algorithm for training AI using preference feedback on entire trajectories. Unlike previous methods, PSPL combines offline and online data to find the best policy, offering theoretical guarantees on regret. The algorithm's performance improves significantly with larger datasets and more competent raters. Researchers at ETH Zurich developed RIGNO, a new graph neural network for solving partial differential equations, PDEs, on complex shapes. Unlike other methods, RIGNO directly handles point cloud data, achieving resolution invariance and temporal continuity. It outperformed existing methods on 12 datasets, showing accuracy improvements up to an order of magnitude. Researchers at MIT and the University of Cambridge, along with colleagues from NTT Research, found that simply having disentangled representations isn't enough for compositional generalization. Their 2D Gaussian bump experiment showed that even with factorized inputs, models often fail to extrapolate to unseen data. They found that enforcing factorization in the output space through regularization or curated datasets significantly improved out-of-distribution performance. Researchers at INFN and CERN, along with scientists from MIT and others, developed DYNAMO, a new anomaly detection system for particle physics. It uses evolving histogram templates and both statistical and machine learning methods to adapt to changing conditions. Across 1,000 tests, the statistical version achieved a median balanced accuracy of 0.947. Researchers at the University of Freiburg developed a new method for solving the inverse multi-armed bandit problem. It uses convex optimization after a variable transformation, achieving similar performance to Monte Carlo methods, but 10 times faster in some tests. Researchers at Peking University and Northwestern University, along with teams from ByteDance and the University of Minnesota, developed BRIE. This new algorithm uses reinforcement learning to automatically generate high-quality reasoning steps for LLMs. BRIE achieved a 10-point accuracy boost on a math benchmark, outperforming methods using human annotated data. Researchers at Massachusetts General Hospital and Harvard Medical School, along with a team from several other institutions, developed a new MRI super-resolution model. It uses a conditional latent diffusion model and progressive distillation to create a smaller, faster model that works on different resolution MRIs without retraining. The student model achieves a 59% reduction in FLOPs and a 69% reduction in parameters compared to the teacher model. Researchers at the University of Cambridge and Octiocore Limited reviewed 5,576 studies on AI for IVOCT heart scans. Only 35 passed quality checks. The review highlights methodological flaws and biases in current AI models for diagnosing coronary artery disease. Researchers at Tsinghua University and the Shanghai Qi Zihe Institute developed UP-VLA, a new vision language action model. Unlike previous models, UP-VLA combines multimodal understanding and future prediction during training. This resulted in a 33% performance boost on the Kelvin benchmark. Researchers at EPFL and NVIDIA developed a new method for 3D surface reconstruction. Instead of using volumes, they directly optimize a surface distribution. Their modified instant NGP implementation achieves a PSNR only 0.1 decibels lower than the volumetric approach, with comparable speed. Researchers at University College London developed a new protocol for 3D cell segmentation in dense tissues. They used 2-photon microscopy and a human-in-the-loop pipeline with CellPose, TrackMate, and Napari. Manual correction of a single 100-cell stack took a week. Researchers at the University of Toronto and the University of Science and Technology of China, along with Microsoft Research Asia, developed CAD Fusion. It's a new text-to-CAD system that uses LLMs and visual feedback. Unlike previous methods, CAD Fusion alternates between sequential learning and visual feedback stages, creating 1,500 preference pairs per iteration. Researchers at Carnegie Mellon University and Microsoft Research, along with colleagues from other institutions, developed OffCMAB, the first offline learning framework for combinatorial multi-armed bandits. It uses pre-collected data, unlike previous online-only methods. CLCB, their new algorithm, achieves near-optimal results. Researchers at the University of Kent and University College London developed a new method for improving satellite images. It uses manifold fitting to enhance images from rotating synthetic aperture systems. This resulted in a 13.34% PSNR and 36.19% SSIM improvement over existing methods. Researchers at Tsinghua Shenzhen International Graduate School and Pengcheng Laboratory, along with others, developed IoT Gen, a framework using LLMs to create synthetic smart home data. This solves the problem of static datasets that can't adapt to changing user behavior. The system compresses massive datasets, 914K minus 3,657K tokens, before LLM processing. Researchers at the University of Sydney and ServiceNow developed nitrogen monoboride-LoRa, a new method for fine-tuning AI models. Unlike standard LoRa, NB-LoRa controls both the rank and the Schatten p-norm of the adaptation matrix. This leads to improved robustness to hyperparameters and less forgetting of pre-trained knowledge. Researchers at Tsinghua University and Bloomberg, along with a team from other institutions, re-examined diffusion posterior sampling (DPS). They found DPS doesn't work as previously thought. Instead of approximating conditional scores, it's closer to maximizing a posterior. Their experiments showed a large score mean, 5.8568, for DPS, far from the ideal 0. Researchers at Incuria and EPFL found a surprising link between convex optimization theory and how learning rates are scheduled during large language model training. They used this to improve training of 124M and 210M parameter llama-type models. The theoretical bound closely matched real-world loss curves. Researchers at Peking University and Fuzhou University, along with other institutions, developed NoFRE. It's a new sequence labeling model that uses LLMs to improve low-resource performance. With just 250 training samples, it outperformed existing methods by an average of 1.95%. No FREE, handles nested entities efficiently and doesn't need extra knowledge during inference. Researchers at Wuhan University and Microsoft, along with a team from several other universities, developed Service Odyssey. This self-learning agent system autonomously manages microservices without needing prior service knowledge. 3 trials cost under $10 each and finished in under 30 minutes. Researchers at University College London and University of Oxford created Motion PCM, a new model for real-time motion synthesis. It uses a phased consistency model to avoid noise issues in other methods, achieving high-quality results with fewer than 4 sampling steps. Researchers at MIT and Nanyang Technological University, along with colleagues from IZA and the University of Bonn, studied how AI systems show bias based on surnames. They used 600 surnames from the US and Thailand, finding that elite surnames significantly impacted AI perceptions of wealth and intelligence, affecting decisions in hiring and loan approvals. Researchers at MetaGen AI and ETH Zurich improved large language model LLM speed. Their judge decoding method trains a small module to check if generated words are correct, not just if they match the main model's output. This led to a 9x speedup for Llama 405B, reaching 129 tokens per second. Researchers at CNRS and ENS Paris, along with colleagues from other institutions, developed a new conformal prediction method. It uses optimal transport to handle multivariate data, creating flexible prediction regions unlike previous methods. The method guarantees coverage within alpha ±2, n+1. Researchers at Google DeepMind and the London School of Economics, along with colleagues from other institutions, explored a new way to align large language models, LLMs, with human preferences. They replaced RLHF with maximal lotteries, a probabilistic social choice rule. Experiments showed this approach better reflects aggregate preferences, handling non-transitive preferences and irrelevant alternatives more effectively than RLHF. Researchers at the University of Tokyo found that the generalization performance of physics-informed linear regressors depends on the dimension of the associated affine variety, not just the number of parameters. This new approach works for both linear and nonlinear equations. Researchers at National Tsinghua University and National Yangming Chiaoteng University, along with colleagues from 2 other universities, found 3 statistical laws, ZIFs, heaps, and Benfords, in images. They used a pre-trained convolutional neural network, VGG19, to define image words, and found that ZIFs and heaps laws held strongly, r² greater than 0.94, even with image distortions. Researchers at UCLA and Carnegie Mellon University created BCAT, a new model for predicting fluid dynamics. It uses a block causal transformer and next frame prediction, improving accuracy by 2.9x and speed by 185x over previous methods. Researchers at MIT CSAIL and Columbia University, along with a team from ETH Zurich and Google Research, developed a new method for generating 3D procedural materials. They fine-tuned a vision language model on a dataset of over 550,000 materials, a 330x increase, to generate Python code directly from input images, unlike previous methods. Researchers at Relation and the MRC Biostatistics Unit, along with teams from MIT and Harvard, present a new semi-mechanistic framework for deep learning in regulatory biology. This framework addresses the underperformance of deep learning compared to simpler methods in predicting gene expression by explicitly modeling experimental steps and highlighting hidden assumptions. Researchers at Peking University and NYU, along with a team from UC Berkeley, studied how to best spend computational resources when training AI models using synthetic data. They found that exponentially increasing the amount of data used in each training iteration significantly outperforms constant strategies, sometimes reducing costs by up to 60%. Researchers at KAIST developed a new way to predict how large language models, LLMs, will respond to prompts. Their method, using sparse autoencoders, achieves up to 0.994 correlation with actual LLM behavior, while being 235 times faster. Researchers at the University of Illinois and Analog Devices, along with a team from Bilkent and Maryland, studied task offloading in multi-access edge computing. They used mean field game theory to create distributed solutions, improving resource use by 37% in a priority access scenario. The study also incorporated the age of information metric. Researchers at Inquiria, and the University of Montpellier, along with other teams, studied meta-learning. They extended it beyond simple linear regression to more complex, convex problems. Amazingly, they showed that even with just one data point per user, the system can still learn, though it needs many users. Researchers at the University of Illinois Chicago and Stanford University studied weak-to-strong generalization in AI. They extended existing work beyond squared loss to Bregman divergences, including cross-entropy. Their method uses a convex combination of 100 strong models, minimizing a reversed KL divergence. Experiments on synthetic and real-world datasets showed a correlation between misfit and performance gain. Researchers at MIT and UT Austin improved conditional image generation in diffusion models. Their new rectified gradient guidance (REG) method corrects a theoretical flaw in existing guidance techniques. Experiments show FID score improvements up to 0.58 points. Researchers at Sony AI and EPFL, along with teams from Sony Semiconductor Solutions Europe and Japan, developed a new method for black box optimization. It uses a locality-aware surrogate model to improve gradient estimation, achieving over 27% relative error reduction in some tests. This is different from previous methods that use a single global model. Researchers at EPFL developed a new method for job allocation using reinforcement learning and graph neural networks. This avoids manual data annotation, unlike previous methods. Their model achieved over 98% approximation ratios on real-world and synthetic datasets. Researchers at the University of Waterloo and NVIDIA found that large language models, LLMs, sometimes create code using fake software packages. They measured hallucination rates from 0.22% to 46.15% across Python, JavaScript, and Rust. This study provides a more detailed analysis of this issue than previous research. Researchers at the National University of Singapore and Nanyang Technological University, along with colleagues from other institutions, developed Safety Chain of Thought, SCOT. SCOT is a new defense against LLM jailbreaks. Unlike older methods, SCOT makes the LLM think before answering, reducing attack success rates to near zero across 10 different attack types. Researchers at the University of Toronto and Stanford University, along with a team from other universities, studied vehicle repositioning in one-way car sharing. Their new algorithm uses only censored demand data, unlike previous methods. This lets them learn efficiently, even with missing sales info. Each shared car replaces up to 20 private cars. Researchers at MIT and Harvard CMSA studied the inductive bias of ResNets. They found that even with skip connections, embedding/unembedding layers create a bias towards low-rank solutions. This contrasts with previous work and is quantified by explicit formulas for minimum norm weights. Researchers at Meta AI developed TOKENTUNE, a new method for fine-tuning large language models. It reduces memory usage by only updating a subset of input tokens during backpropagation. Fine-tuning Llama 2 to 7B with TokenTune and QLORA uses 79% less memory than full fine-tuning. Researchers at Georgia Tech and UT Austin developed new AI deception techniques. They used two strategies to mislead adversaries about a system's goals. One strategy achieved 98.83% of optimal performance while successfully deceiving. The other reached 99.25%. Researchers at Yale University developed a new algorithm for recovering matrices from noisy data. Unlike previous methods, this one needs no extra assumptions about the matrix's spectrum. It uses a clever contour integration technique and achieves exact recovery with a sample size scaling only logarithmically with matrix dimension. Researchers at a37.ai and MIT, along with colleagues from Harvard, developed ACOTT. This new algorithm uses ant colony optimization to help LLMs find the best way to solve complex problems. It improved accuracy by 16.6% compared to other methods. Researchers at a37.ai and MIT, along with scientists from Harvard University, developed MINDSTORES. It's a new AI system for Minecraft that uses a natural language memory to learn from past experiences. Unlike other systems, MINDSTORES improves its planning by 9.4% on average. Researchers at Crowdbotics and Upwork compared LLMs and human experts in early-stage requirements engineering. LLMs generated requirements 720 times faster and cost 0.06% as much. Participants rated LLM-generated requirements as more aligned. Researchers at Shanghai University of Engineering Science and Leiden University, along with a team from other institutions, developed FlexiCrackNet. It uses a lightweight SAM encoder for crack detection, handling any image size. It's 37 times faster than the original SAM, achieving over 30 FPS on an iPhone 14. Researchers at LMU Munich and Harvard University studied how to best help vulnerable people. They created a new metric, the Prediction Access Ratio, PAR, to compare improving predictions versus expanding who gets screened. They found that increasing screening capacity by 25% was needed to cover 75% of high-risk individuals.
That's the end of today's paper highlights. Great job you made it this far. Now go conquer your